Hello students, today we will discuss about our next article, that is law of conservation of electric charge. Now what is law of conservation of electric charge? According to the law of conservation of electric charge, total charge on an isolated system remains constant. Total charge means sum of the positive and negative charge inside the system always remains constant. Now we will discuss the example of the law of conservation of electric charge. Our first example is of glass rod and silk cloth. We have already discussed that when a glass rod is rubbed against the silk cloth, then due to friction, both the bodies acquire equal and opposite charge after rubbing due to the net transfer of electrons from one body to another. In this example, the total charge on the system before and after the rubbing remains conserved. We will discuss it. Let us consider this is our glass rod and this is the silk cloth. Now, here is the system of two bodies. This is the system of two bodies. Now, this is the case of before rubbing. Before rubbing, this glass rod, let us consider having charge Q1 and equal to 0. Before rubbing, glass rod having no charge, equal to 0. And similarly, this silk cloth, before rubbing, let us consider charge Q2, which is also 0. Hence, the net charge is equal to Q, and Q is equal to Q1 plus Q2 is equal to 0 plus 0 is equal to 0. Net charge before rubbing on this system is 0. Now, when we rub the glass rod against the silk cloth, then we find that they acquire the charge. This is glass rod and this is the silk cloth. Now, system of two bodies, system of two bodies. Now, let us consider after rubbing. This is the case of after rubbing. Now, let us consider after rubbing, glass rod lose only one electron and the silk cloth gain this one electron. Then by losing one electron, glass rod acquire charge Q1, which is equal to plus 1.6 into 10 raised to power minus 19 coulomb. And by gaining one electron, the silk cloth acquired the charge Q2. Now this silk cloth gained the electron, and we know that when a body gains the electron, it acquires the negative charge. So due to gaining a single electron by the silk cloth, it acquired minus 1.6 into 10 raised to power minus 19 coulomb charge. Now, after rubbing, the net charge on the system net charge is equal to Q, and Q is equal to Q1 plus Q2, that is plus 1.6 into 10 raised to power 19, ठीक है, plus and minus 1.6 into 10 raised to power 19 coulomb, and this is equal to 1.6 into 10 raised to power minus 19 minus 1.6 into 10 raised to power minus 19 equal to 0. Therefore, Q is equal to 0. So, before rubbing, the net charge on the system is 0, and we find that after rubbing, the total charge on the system also remains 0. And hence we find that total charge before and after rubbing the glass rod with silk cloth remains same on the system. This is the law of conservation of electrical charge. In this case here, we find that when the glass rod lose electron, then the silk cloth acquire the same number of electrons. The charges are not created in the glass rod and the silk cloth. The charges are only transferred from the glass rod to the silk cloth. The amount of charge which is lost by the glass rod, the same amount of charge is gained by the silk cloth, and hence the net charge on the system remains conserved. Due to this reason, the total charge on the isolated system always remains conserved. Now we will consider the second example. We find that in the radioactive decay process, electric charges also remains conserved. Here we will consider the example of decay of uranium-92-238 into thorium with the emission of a helium particle, alpha particle. In this example, that is, we have uranium-92-238. It undergoes radioactive decay process. Uranium-238 decays into thorium. Thorium is 234 and 90, and with the emission of alpha particle. Alpha particle is helium-24. This is our parent atom, and here thorium is daughter atom, and this is alpha particle. This is alpha particle. Now, in this process, that is, this is the before decay process. Before decay process, and here after the decay process. This is before decay and this is the after the decay. Now the total charge on the system before decay is 92, total charge Q 92E. Here 92 is the Z number, atomic number. Atomic number means number of electrons or proton present in the atom. So how many electrons present? 92, and charge on one electron is E. Then the total charge on the uranium-92-238 is Q, and Q is equal to 92E. And similarly, the total charge on the system after decay process is, this is on thorium is 90E, and on alpha particle is that is 2e, and the total charge becomes, that is 92e. Here we also find that the total charge, net charge before decay and the net charge after decay is constant. Hence this example also follow the law of conservation of electric charge. Thank you very much.